Hello there, and welcome to the Sleepy Space Channel. Nobody who boards a generation ship ever arrives anywhere. That is not a flaw in the plan, it is the plan. The nearest star sits 4¼ light-years away, and a vessel able to carry people and then slow down again at the far end crosses that gap at around 1% of the speed of light. The crossing takes something over 4 centuries. 15 generations are born aboard, live their entire lives aboard, and die there, having seen neither the system they came from nor the one they are traveling toward. Tonight, we go aboard with them and stay, through the manufactured evenings, the sky that never changes, the children who have never seen weather, and the long middle in which the ship quietly stops being a journey and becomes the world. If you find these explorations worth your time, a like or a subscribe helps the channel reach others who do. Thank you for being here. But for the next 2 hours, none of this is anything you need to carry. Settle in. Let your shoulders soften. Let your breathing slow. Let the day fade away behind you. Let's begin. Part 1. The last day, inside the solar system. The nearest star system to our own sits about 4¼ light-years away. That is roughly 40 trillion kilometers, or about 25 trillion miles, and it is the shortest interstellar distance that will ever be available to anyone leaving from here. Every serious proposal for a crewed crossing aims at it, because there is nothing closer and nothing easier. At the far end, there is a bright yellow star very much like our own, an orange companion somewhat cooler and smaller, and a faint red dwarf drifting far out on its own long orbit. The two larger stars circle each other on a stretched ellipse that takes about 80 years to complete. The red dwarf is invisible to the unaided eye and needs 500,000 years to go around them once. A generation ship is not defined by its engine. It is defined by its arithmetic. At 1% of the speed of light, which is about 3,000 kilometers per second, the crossing to that system takes something like 425 years. At 0.5%, it takes 850. At 2%, it takes a little over 200. These are the speeds a crewed vessel can realistically reach and, more importantly, realistically shed again at the far end. The concepts that reach 1/10 of the speed of light are almost all uncrewed probes with no braking system at all. They are designed to fly past their target in a matter of hours and keep going. The moment a mission has to carry people, slow down and stop, the practical speed collapses back into the low single digits, and the journey becomes longer than any human life. That is the entire reason the generation ship exists as an idea. It is not a romantic choice. It is what remains when you accept the distance, accept the physics of slowing down, and refuse to give up on carrying people. 425 years, at a generation of 25 to 30 years, means 15 to 17 generations. Counted backward from now, the same span reaches the age of the first telescopes. Everyone who has lived and died between that moment and this one would fit inside a single crossing. If the ship travels at 0.5% of light speed instead, the number rises past 30 generations, and the span reaches back before the printing press. The ship itself would be enormous. Crude interstellar concepts run from tens of thousands of tons for the barest possible vessel to several million tons for versions that carry a genuinely self-sufficient population. One of the mid-century nuclear pulse studies scaled all the way to around 8 million tons. In almost every one of these designs, the propulsion section is a small fraction of the whole. The overwhelming majority of the mass is habitat, shielding, water, atmosphere, agriculture, and the industrial capacity to remake broken things. The ship is a small, closed world with an engine attached to one end, and the engine is the least of it. The departure would be undramatic. A vessel built for centuries does not leap away from anything. Continuous low thrust means an acceleration of a fraction of a percent of Earth's gravity, and at that rate, nobody aboard would feel a launch at all. There would be no pressing back into a seat, no roar, no moment of separation. There would be a schedule, a set of confirmations, and a number on a display beginning to climb. Reaching 1% of light speed at 1/100th of a gravity takes about 8 years of continuous burning. At 1,000th of a gravity, it takes 80. The acceleration phase alone can be longer than a career, and in the slower designs, it is longer than a childhood. During those years, the solar system falls behind in stages that are easy to name and almost impossible to see. The orbit of the outermost planet sits at about 30 times Earth's distance from the Sun. At full cruise speed, that entire span is crossed in under a month. The belt of icy bodies beyond it, spread between 30 and 50 times Earth's distance, passes in a few weeks. There is nothing to watch. The objects out there are separated by hundreds of millions of kilometers, and a ship crossing the region would be extraordinarily unlikely to come within sight of any of them. The boundary where the Sun's outflowing wind finally gives way to the pressure of interstellar gas lies at roughly 120 times Earth's distance. At cruise speed, the ship reaches it about 70 days after the engines settle. Nothing happens visually. The instruments record a change in particle counts and a change in the direction of the magnetic field, and the windows record nothing whatsoever. It is the most significant boundary in the solar system, and it is entirely invisible. Even then, the ship is not out. The Sun's gravitational domain, the enormous sparse shell of icy bodies that surrounds everything, is thought to extend as far as 100,000 times Earth's distance from the Sun. That is about a light year and a half. At 1% of light speed, crossing it takes something like 160 years. Nearly 40% of the entire voyage is spent inside the Sun's own system, and the people living through most of it will have been born aboard and will die aboard without ever hearing the fact discussed. It is not the sort of thing that stays interesting for 6 generations. There is one moment in the first decade that would be genuinely noticeable, and it is not a moment so much as a slow arrival. The Sun stops being a disk and becomes a point of light at roughly 5,000 times Earth's distance from it, which is the range at which its width drops below what the human eye can resolve. The ship crosses that threshold about 8 years into cruise. There is no announcement. One year the Sun is a very small, brilliant disk, painful to look at directly, and still unmistakably a thing with edges. Some seasons later, it is simply the brightest star in the sky. Nobody could point to the day it changed. From that point onward, the Sun behaves exactly like every other star, only brighter. At 1 light year out, it would still be more brilliant than anything in Earth's night sky. At the full distance of the crossing, seen from the destination, it becomes an ordinary bright star among the others, no more remarkable than a dozen of its neighbors, sitting in a constellation that does not exist yet because nobody has drawn it. The interstellar medium the ship moves into is not empty, but it is close. There is roughly 1 atom per cubic centimeter out there, against something like 27 billion atoms in the same volume of ordinary room air. The Sun is currently passing through a warm, partly ionized cloud of that gas, and that cloud sits inside a much larger and much emptier cavity, carved out by ancient stellar explosions. The ship would spend the entire 4 centuries of its voyage inside that same cavity, and would never once encounter anything that could be described as an obstacle. At 1% of the speed of light, relativity is essentially irrelevant. The clocks aboard run slower than clocks on Earth by about 1 part in 20,000, which amounts to a few weeks across the whole 400 years. Nobody aboard is skipping ahead. There is no compression of the journey, no shortcut through time, no sense in which the crossing is shorter for the travelers than for anyone else. The full 4 centuries have to be lived, hour by hour, by people taking turns. And this is the shape of the thing that matters most. A generation ship carries 3 separate populations, and only one of them is really on a journey. The first generation departs, remembers a sky, and understands the mission as a decision they made. The last generation arrives, watches a star grow into a place, and understands the mission as an event about to happen to them. Between those two, there are 10 or 12 or 20 generations who do neither. They are born into a world already in motion. They live entire, complete lives inside it, and they die without any of it changing. That enormous middle is where almost the whole voyage actually takes place, and it is the part almost nobody imagines. The ship leaves as a vehicle. Within a century it has become a place. And only at the very end, 400 years later, does it turn back into a vehicle again. Part 2. The Turning World. Weight aboard a generation ship is manufactured, and it is manufactured by spinning. The habitat is built as a ring or a cylinder, and it is turned steadily about an axis that points along the direction of travel, so that the thrust of the engine and the rotation of the hull do not interfere with one another. What the inhabitants experience as gravity is simply the floor pushing inward, holding them on a circular path they would otherwise leave in a straight line. The strength of that apparent weight equals the radius of the habitat multiplied by the square of the rotation rate. Larger and slower feels correct. Smaller and faster feels wrong in ways that are difficult to describe and impossible to ignore. The trade between size and spin rate is the single most consequential decision in the design of the ship. To produce a full Earth gravity at 2 rotations per minute, the habitat needs a radius of about 224 meters. At 4 rotations per minute, 56 meters is enough. At 1 rotation per minute, the radius has to be nearly 900. Comfort, in other words, is bought with structure, and structure is bought with mass, and mass has to be accelerated and later decelerated across 4 light years. Every meter of radius is paid for twice. The limit on rotation rate is not set by engineering, but by the inner ear. Above roughly 2 turns per minute, a person who moves their head experiences something called a cross-coupled illusion. The fluid in the balance organs responds to the rotation of the habitat, as well as to the motion of the head, and the result is a strong, convincing sensation that the world is tumbling in a direction nobody moved in. Training raises the tolerance considerably. Some people adapt to rates several times higher with practice, and adapt well. Others never adapt at all, and a ship designed at an aggressive rotation rate is a ship that a fraction of its own population would find permanently unpleasant. There is also a gradient. Apparent gravity falls off with distance from the axis, which means that in a spinning habitat, a standing person's head weighs slightly less than their feet. In a 200-meter habitat, the difference across an adult body is under 1%, and nobody would ever notice it. In a 50-meter habitat, it is a few percent, which begins to be perceptible when bending or lying down. In a small centrifuge only 10 meters across, the difference approaches a fifth, and the sensation of standing up is closer to being poured than to rising. Beyond the gradient, there is a set of everyday effects that would define what motion feels like for everyone aboard. Walking in the direction of the spin adds to your speed around the axis and makes you heavier. Walking against it subtracts and makes you lighter. In a large habitat, the difference is a few percent, which sounds negligible and is not. It is enough that people would know which way they were facing without looking, purely from the feeling in their legs. Direction, aboard a rotating world, has a weight attached to it. Dropped objects do not fall straight. As an object falls, it retains the sideways speed it had when released, while the floor beneath it is moving slightly faster, and the result is that the object lands behind where it should. From waist height in a large ring, the drift is a few centimeters. In a small habitat, it is a noticeable hand's width. Every child raised aboard would grow up with that curve built into their reflexes, catching and throwing along paths that would look subtly wrong to anyone from a planet, and would find a straight fall genuinely strange. Height has a cost and a reward. Climbing toward the axis reduces your weight in direct proportion to the distance you have traveled, so the top of a tall room aboard a habitat is measurably lighter than its floor. At the axis itself, there is no weight at all. Ships would put things there that benefit from it. Storage, certain kinds of manufacturing, medical facilities, and almost certainly recreation, because a place where a person can float is the closest thing to a genuinely new experience that a closed world can offer. And the ground curves upward. In a cylinder, the floor rises in both directions and closes over your head, so that the landscape of the world is a continuous loop with no horizon anywhere in it. In a habitat, a few hundred meters across the curve is severe and constantly visible, and the far side of the world hangs overhead, close enough to see individual features. In one several kilometers across, the curve flattens out into something that reads almost as terrain, and the opposite side becomes a distant band of light and shadow that behaves, from a distance, rather like weather. None of this would seem remarkable to anyone born aboard. The curving fall of a dropped cup, the lightness of walking one way and the weight of walking the other, the ground rising in the distance instead of dropping away, are simply what the world does. They would be learned before language, the way the pull of a planet is learned by a child on Earth. It is the recordings of Earth that would look incorrect. A film of an object falling straight down, in a place where the ground curves away from the viewer rather than up toward them, would look like a trick badly done. There is one more piece of the rotating world that would be part of daily life, and it is the least pleasant part. The habitat turns, but the propulsion spine and the docking structures do not. The interfaces between them, where a person passes from the rotating section into the stationary one, are the places where the body is asked to accept that its own weight is a matter of local convention. Passing through means matching rotation, and the transition regions are where motion sickness concentrates. On a ship where those transitions are made daily by maintenance crews, they are workplaces rather than corridors, and they would be staffed by the small fraction of the population who find them tolerable. A spinning habitat is also a gyroscope, and that has consequences the inhabitants would never see, but the ship would live with permanently. A rotating structure resists being turned, so any change of heading has to fight the spin, and a large vessel would either slow its rotation before maneuvering or accept course corrections that take a very long time to complete. The spin has to be actively maintained in other ways as well. Any movement of mass inside the habitat perturbs the axis. Water shifting between tanks, cargo relocated between decks, a large number of people gathering in one section, all of it nudges the balance, and damping systems have to correct for it continuously, for centuries, without a break. Rotation also provides no protection from radiation whatsoever, so every ton of shielding is added on top of every ton the spin already demands. And the games played aboard would grow up around all of it, because any thrown or struck object bends, and bends differently depending on which way around the ring it is traveling. The reason all of this complexity is accepted is that the alternative has been measured, and the measurements are not encouraging. In weightlessness, bone mineral in the load-bearing skeleton is lost at a rate of 1 to 2% per month, against 1 to 2% per year in the fastest terrestrial bone loss. Postural muscle wastes away by around a fifth. The heart loses mass and becomes more spherical. Body fluids shift toward the head and stay there. A majority of long-duration crews develop measurable changes at the back of the eye, including flattening of the eyeball, folds in the retina, and swelling where the optic nerve enters, and in some cases these changes do not fully reverse. For a mission of 6 months, none of that is decisive. For a person who will be conceived, born, grown, aged and buried without ever leaving the habitat, all of it is. And the argument that settles the design is not about the adults at all. It is about children. Skeletal development, muscular development, and the calibration of the balance organs all happen under a gravitational load, and no human being has ever developed under anything other than a full Earth gravity. A ship that chooses a lighter, cheaper fraction of gravity for the sake of a smaller radius is running an experiment on its own descendants across 15 generations, with no control group and no way to stop. That is the deepest gap in the whole idea, and it is worth stating plainly. Human physiology has been measured at 1 gravity and at effectively none, and nowhere in between. Everything in the middle is extrapolation from 2 points. A designer choosing between a full gravity and a third of one is choosing without data, and would remain without data until the ship had been running long enough for its own children to provide it. There is a possibility worth holding, though, and it is a gentler one. The inner ear calibrates itself during development. An infant raised in a rotating habitat, whose balance organs learn the world with the rotation already present, might tolerate spin rates that would incapacitate an adult from Earth entirely. It is plausible that the shipborne would move through their turning world with no discomfort at all, and would find the very idea of motion sickness from rotation as abstract and remote as we find the idea of being unable to stand up. Part 3. The closed loop. Everything a person aboard consumes must come back. That is the whole principle, and it is more demanding than it sounds. An adult uses a little under a kilogram of oxygen each day and exhales roughly a kilogram of carbon dioxide. 2.5 to 3.5 liters of water are taken in as drink and food, but the total daily water demand, once washing, laundry, and food preparation are included, runs to tens of liters per person. Something between half a kilogram and a kilogram of dry food is eaten. Multiply any of those by a population of 1,000 and by 425 years, and the numbers become impossible to carry. Oxygen alone would run to hundreds of thousands of tons. Nothing can be stored. Everything has to circulate. Food is the part that cannot be faked at all. It has to be grown continuously for the entire crossing. Under lights, the ship powers itself. Estimates for intensive hydroponic agriculture supporting a fully plant-based diet run from roughly 20 to 50 square meters of continuously cropped area per person, and that is the growing area alone. Add propagation, processing, drying, storage, and the reserve capacity needed to survive the loss of any single module, and the figure roughly doubles. A crew of 1,000 implies a working farm measured in tens of thousands of square meters, running every day for centuries, with no fallow years and no bad harvests permitted. What is known about closed ecologies is not reassuring, and it is worth being honest about it. The most famous large sealed ecology experiment ever run lost oxygen steadily and unexpectedly. The atmosphere fell from a normal 21% oxygen to around 14.5% over about 16 months. The people inside developed the symptoms of altitude sickness while standing at sea level, and oxygen eventually had to be injected from outside to keep them functional. The system had been designed, modeled, and instrumented by capable people, and it went wrong anyway. What makes that episode instructive is not the failure, but the way it hid. The oxygen was being consumed by microbes in the soil, faster than anyone had modeled. That should have shown up immediately as a matching rise in carbon dioxide, which is the standard signature of respiration. It did not, because the concrete of the structure was still curing, and curing concrete absorbs carbon dioxide out of the air. Two unrelated processes cancelled each other in the readings. The instruments were working perfectly, and the picture they painted was wrong. For most of a year, the most closely monitored ecosystem ever built was quietly failing in the one way its monitoring could not see. The same experiment demonstrated something else that any ship would have to plan around. Closed ecosystems simplify. Every pollinating insect species inside that structure died out. Ants and cockroaches, which nobody wanted, thrived. Vines overgrew the crops. A sealed system does not settle into balance on its own. It slides toward a smaller and hardier set of survivors, and holding it richer than that requires constant, deliberate, informed intervention by people who understand what they are looking at. Smaller and less ambitious closed facilities have done considerably better. A compact research installation running on algae and wheat sustained small crews for up to half a year, with near total recycling of air and water and roughly 85% closure on food. The lesson from comparing the two is not encouraging or discouraging so much as clarifying. Closure is achievable when the system is small, simple, and ruthlessly managed. It becomes harder in direct proportion to how rich, various, and pleasant the ecology is. A ship has to be both, and that tension never resolves. The response to that instability, in the research that has followed, has been to stop asking a single ecosystem to hold itself together. The more promising designs break the loop into a chain of separate compartments, each doing one job under controlled conditions. One breaks down waste. One runs photosynthetic bacteria. One converts ammonia into nitrate. One grows algae. One grows higher plants for food. Each compartment is simple enough to be understood, monitored, and repaired on its own terms, and the fragile emergent behavior of a whole ecosystem is replaced by a series of industrial processes that happen to be alive. It is less beautiful than a sealed garden, and considerably more likely to still be working in the year 300. Even the choice of what the plants grow in is unsettled. Real soil is heavy, biologically unpredictable, and takes centuries to form, and the sealed ecology experiment that lost its oxygen lost it to soil microbes. Hydroponics is lighter, cleaner, and precisely controllable, and it has no buffering capacity at all. When a nutrient solution goes wrong, every plant standing in it goes wrong at the same time, within hours. Soil forgives mistakes slowly. Hydroponics does not forgive them at all. A ship would probably carry both, in separate volumes, for the same reason it carries everything else twice. And the ecology aboard would have to include organisms nobody would choose to live with. Pollinators are needed, which means insects. Waste breakdown needs invertebrates and a working microbial community. A ship's biology is not a garden curated for pleasure. It is a working system that contains things people would rather not see and cannot afford to lose. The atmosphere aboard would also accumulate things nobody put there. Sealed volumes fill up with volatile organic compounds given off by materials, by people, and by plants. Ethylene, released by ripening fruit, builds up in an enclosed space and damages the crops that produced it. Continuous atmospheric scrubbing is not a refinement but a life support function, and the scrubbers themselves are machines that must be maintained, replaced, and eventually manufactured aboard by people whose ancestors installed the originals. All of which gives the air aboard a particular character. It has a smell. Every sealed habitat develops one, from its materials, its plants, its people, and its machinery, and it is not unpleasant so much as absolutely constant. It is the smell of everywhere, and it would be invisible to anyone raised in it and immediately obvious to a visitor, if a visitor were possible. The air moves only because it is made to move. Without weather, without the great convective engines of a planetary atmosphere, air in a habitat goes where fans push it and nowhere else. Still corners collect exhaled carbon dioxide. Ventilation runs every hour of every year for 4 centuries, and the ship's ductwork is as much a survival system as its hull. Humidity is a decision rather than a condition. There is no rain, no evaporation from an ocean, no dew. Every percentage point of moisture in the air is produced, distributed, and maintained on purpose, and the agricultural sections would be noticeably more humid than the residential ones, a difference a person could feel walking between them, and one of the very few environmental variations the world contains. And the water is never new. The same water passes through people, plants, condensers, and filters thousands of times across the crossing. Nothing aboard is ever more than a few weeks removed from having been part of somebody. Modern spacecraft already recover water from cabin humidity, from washing, and from urine, and recover more by reacting exhaled carbon dioxide with hydrogen to make water out of waste breath. A generation ship would push all of that toward totality, because a 1% loss per year compounds into nothing over 400 years. Nitrogen is the quiet problem underneath all of it. Most of the atmosphere, by volume, does no chemical work at all. It provides pressure and dilutes the oxygen, and that is enough to make it essential. But it is lost slowly through airlocks, through seals, through every operation that opens the ship to the outside, and there is no easy way to make more. Of all the bulk supplies aboard, nitrogen is the one with the least forgiving arithmetic. The other elements do not disappear, but they do get locked into places that are hard to recover from. Salt, phosphorus, and trace metals accumulate in filters, in biofilms, in the structure of long-lived plants, and in the bodies of the dead. A 4-century loop needs a recovery path for every element it depends on, and the ones that get overlooked are the ones present in small quantities and absolutely required, which is exactly the category most likely to be forgotten in the design. Because of all this, the most frightening events aboard a generation ship would not be loud. In a closed world, catastrophe announces itself as a slow discrepancy. A fractional oxygen decline over 11 months. A nitrogen reading that has drifted a little further than the previous drift. A crop yield down 4% for 3 seasons running, in a system where 4% is inside the normal variation and 3 seasons is not quite long enough to be certain. There is no alarm for any of that. There is a person looking at a column of numbers, in a room that smells the way it has always smelled, working out that something in the loop has been quietly wrong for a long time. The standard mitigation is not better farming. It is more farms. Several separately sealed agricultural volumes, with independent atmospheres and no shared water, so that a blight, a pest, a chemical contamination, or a slow mechanical failure in one of them cannot reach the others. Redundancy, not efficiency, is what closed system engineering rewards, and a generation ship would be built to be inefficient on purpose, over and over again, in every system that people cannot live without. Part 4. The sky that does not change. There is a picture people carry of what interstellar travel looks like from inside, and it involves stars streaking past. Nothing like that would happen. At 1% of the speed of light, the apparent displacement of starlight caused by the ship's own motion amounts to about half a degree, which is roughly the width of the moon in Earth's sky. It is a real effect, and it is measurable with instruments. It is not visible. There is no tunnel of light, no bending of the constellations, no forward compression of the sky, and no visual sign of speed of any kind. The stars simply hold still. Over 400 years of travel, the pattern of the sky shifts by an amount comparable to a few centuries of ordinary stellar drift as seen from Earth, which is to say, by an amount you would need careful measurements to detect. Someone looking out a window in the first year of the crossing and someone looking out in the 400th would see very nearly the same arrangement of points. 15 generations would grow up under an identical sky. The band of the Milky Way would lie across it in exactly the same place for all of them. Only two things visibly change across the entire voyage, and they change slowly. Behind, the sun dims. Ahead, the destination brightens. Everything else is fixed. The complete visual record of a 400-year journey is 2 points of light gradually trading places, and neither of them does anything a person could notice within a single lifetime. The sun's decline is the more affecting of the two, and it is worth being precise about it. For the first years, it is a shrinking disk. After about 8 years of cruise, it is a point, and from then on it behaves exactly like a star. At 1 light-year out, roughly a century and a half into the crossing, the sun would still be brighter than anything in Earth's night sky, brighter than Sirius, brilliant enough to cast a faint shadow. By the halfway mark, it has faded to something ordinary. From the destination itself, our sun is a modest, bright star among a great many others, sitting in a constellation nobody has drawn, and the only thing that distinguishes it is that a particular ship's records say which one it is. The destination brightens on the mirror image schedule. It grows 4 times brighter every time the remaining distance halves. From the very first day, it is the brightest thing in the forward sky, and it stays the brightest thing in the forward sky for 4 centuries, becoming gradually and unmistakably more so. But it does not become a place. A star does not resolve into a disk until you are within a few times Earth's distance from it, and that means the target remains a point of light until the ship is essentially already there. The transformation from star to sun happens entirely inside the final generation's lifetime, which means the defining visual fact of a generation ship is not spectacle. It is stillness. The ship is traveling at 3,000 kilometers per second, covering more than 600 times Earth's distance from the sun every single year, and the view out the window says absolutely nothing about it. Motion at interstellar scale is invisible from inside. There is nothing to pass, nothing to overtake, nothing near enough to slide by. A person could stand at a window for an entire lifetime and never see the ship do anything at all. Whether there would be windows is a genuine question. Shielding argues hard against them, because every window is a thin place in a hull whose entire purpose is to be thick, and the direction of travel is precisely where the dust arrives. Any forward-facing port is the most exposed surface on the vessel. Psychology argues just as hard in favor, because enclosed environment research finds consistently that a real view outward matters to people in confinement in a way that a displayed image does not, even when the displayed image is objectively better. The usual compromise routes light and view through mirrors, light shafts, or heavily shielded ports, which means the sky aboard is a curated and engineered thing even on the occasions when it is genuinely real. What is actually out there to see is almost nothing. The interstellar medium at roughly 1 atom per cubic centimeter emits nothing the eye can detect and blocks nothing either. There is no fog, no haze, no texture, no sense of a medium being moved through. The space between stars looks exactly like empty black, because that is very nearly what it is. The dust is rare and consequential in a way that is entirely invisible. Interstellar grains number something like 1 per million cubic meters. A ship traveling at 1% of light speed will meet a great many of them over 4 centuries, and a single grain weighing a microgram carries kinetic energy comparable to a rifle bullet at that speed. It is a serious engineering problem, and it produces no visible event whatsoever. The forward shielding is being sandblasted continuously for 400 years by something nobody aboard will ever see. The background out there is genuinely cold. The residual glow left over from the early universe sets a floor a little under 3 degrees above absolute zero, and everything the ship radiates goes out into that. It is the coldest environment available anywhere, and it is also the reason the ship can shed heat at all, which is the only cooling mechanism a vessel in vacuum possesses. It is worth noting that a faster ship would see something. At 1/10 of the speed of light, the aberration of starlight grows to about 5.5 degrees, and the forward sky is measurably crowded together and shifted toward the blue, while the rear sky thins and reddens. At half of light speed, the effect becomes dramatic. But a generation ship is precisely the design that does not go that fast, and the stillness of its sky is a direct consequence of the same slowness that makes the voyage take 15 generations. The ship trades the view for the possibility of stopping. Looking backward, the shapes would still be recognizable for the entire crossing. 4.25 light-years is a small distance by the standards of the stars whose light makes up the constellations, most of which are tens or hundreds of light-years away. The patterns would stretch very slightly, the nearest few stars would shift by a noticeable amount, and everything else would hold. A person raised aboard could look back toward where the ship came from and see, essentially unchanged, the same figures that people on Earth had been naming for thousands of years before the ship left. Even the great boundary crossings produce nothing to look at. When the ship passed out of the sun's wind and into interstellar gas, an event that in every diagram is drawn as a shell with an edge, the windows showed exactly what they had shown the day before. Only the particle counters knew. There would be no dawn, no dusk, no clouds, no rainbows, no meteors, and no weather in the sky for 400 years. Every sky event aboard would be an event the ship itself produced. That is worth sitting with, because it is the single largest difference between life aboard and life anywhere a human being has ever lived. Every environment our species has occupied has had a sky that did things. The shipborne would have a sky that does one thing, permanently, which is to be there. There is a compensation, though, and it is a real one. A ship in motion has the finest observational platform ever available to anyone. After a single year of cruise, the baseline between where it started and where it is has grown to more than 600 times Earth's distance from the Sun, which is a parallax baseline no observatory on or near a planet can approach. Distances to nearby stars could be measured aboard with a precision nobody at home could match. The ship would also almost certainly steer by pulsars, the regularly flashing remnants of dead stars that provide a timing reference usable anywhere in the galaxy, since there is no landmark at all in the middle of a crossing and nothing else to navigate against. And there is one small unfolding to look forward to. The destination is not one star, but 3. Somewhere in the later centuries, the single bright point ahead separates into 2, as the yellow star and its orange companion draw far enough apart in the sky to be told apart by eye. Much later, and far off to one side, a third and much fainter point can be picked out. It is the only thing in 400 years of sky that ever becomes more than it was. Part 5. The weather of a made world. Aboard a generation ship, there is never silence. Fans run continuously. Pumps move water and coolant. Compressors cycle. Air handlers push atmosphere down corridors that would otherwise stagnate. Beneath all of it, there is the low structural note of a hull turning about its axis, a sound felt through the floor as much as heard. Orbital habitats already run at noise levels comparable to a busy office, and long-duration crews show measurable hearing loss from years of exposure to it. A ship built for centuries would have to do far better, and would still never be quiet. The important thing about that background noise is what it means. A truly silent ship is a ship whose air is not moving, whose coolant is not circulating, whose water is standing still. Silence aboard is not peace. It is the sound of a system that has stopped, and everyone aboard would understand that, instantly and without being taught, the way a person on Earth understands the smell of smoke. The hum is the sound of being alive, and it would run without interruption for 400 years. Sound also travels differently in a sealed structure. A hull of metal and composite carries vibration along its frame, far better than air carries it through a room, so a repair being made at one end of a habitat is audible, faintly, at the other. The ship gossips structurally. A person who has lived in one section for 40 years would know the difference between the note of a pump running normally and the note of a pump running slightly out of balance, and would know it from 200 meters away through a floor. What is absent is everything else. There is no thunder, no wind moving through anything, no rain on any surface, no surf, no birds, no insects outside the agricultural sections, no distant traffic, no weather of any kind making any noise at all. The entire acoustic environment consists of machinery, of people, and of whatever recordings someone has chosen to play. Every natural sound aboard is a decision that was made, and most of them were made by people who died 3 centuries ago. Time is manufactured in the same way. There is no sunrise, so the day has to be invented. The lighting cycle is chosen, and it has to be chosen because the human circadian rhythm free runs slightly longer than 24 hours and drifts steadily without an external cue to hold it. A population left to its own devices under constant illumination would scatter across the clock within weeks, and a closed world cannot afford a population that is awake at random. So the light does the work. Bright, blue-weighted illumination in the habitat morning, warm, dimmer light in the evening, a gradual transition between them that takes the better part of an hour. This is not decoration. It is the mechanism that holds an entire society's sleep in phase, and it has to run correctly for 15 generations. The lamps that do it are life support hardware in exactly the same sense as the oxygen system, and they would be maintained with the same seriousness. The ship's evening would be a real event, even though nothing about it is natural. The overhead panels warm from white toward amber over about 40 minutes. The ventilation drops half a tone as the night flow rate engages. The agricultural sections go dark in sequence, section by section, on a schedule set by what is growing in each. It is not a sunset. It is a very good imitation of one, running to a specification, and it has run without interruption for 300 years. Children would find it beautiful for the same reason children on Earth find sunsets beautiful, and neither group would be wrong. Seasons would probably be invented too. Agriculture needs them, since many crops require a cold period or a change in day length to set fruit. But there is also a case for them that has nothing to do with farming. Human well-being appears to benefit from environmental variation, and sameness in a confined space is corrosive in ways that accumulate slowly. A ship might run a slow annual cycle of light color, temperature, and day length across its whole habitat, not because anything requires it, but because a world in which nothing ever changes is a difficult place to spend a life. The calendar itself loses all its anchors. A year aboard means nothing astronomically. There is no orbit, no axial tilt, no returning position of anything. Ship time would be a pure convention, kept because people need one, and it would drift from any Earth reckoning within a few generations. So would the units. A ship that gradually redefines its measurements for local convenience would, over centuries, lose the ability to check itself against its own original engineering documents, and nobody would notice until they needed to. What is known about how people fare in this kind of environment is thin, and the thinness matters. The longest sealed isolation studies ever run last about 500 days. Antarctic overwintering runs to 9 months. Submarine patrols run to a few months. Nothing in the entire human record approaches even one shipboard generation, let alone 15. Everything said about the psychology of a generation ship is extrapolation from experiments that ended before the first child would have been born. What those studies do show is consistent, though. There is a reliable mid-mission slump, arriving somewhere around the halfway point and lasting a long time. Communication with the outside declines over the course of a mission, often sharply, as crews turn inward and treat ground contact as an intrusion. Small in-groups form and harden. And morale depends far more on meaningful work than on comfort. Crews given genuinely important tasks do well in poor conditions. Crews given comfortable conditions and busy work do badly. But there is a difference between all of those studies and a generation ship, and it is the whole difference. Every one of those experiments had an outside. The participants knew the date they would walk out. The hardship was bounded, and the boundary was the thing that made it survivable. Aboard a generation ship, the middle generations have no such date, because within their lifetime there is no outside to walk into. Their situation is not confinement in the way the studies define it. It is simply where they live, and it is where everyone they know lives, and it has been that way since before anyone can remember. Which changes what matters. Privacy becomes a resource rather than a preference, and in closed environment research is consistent that the ability to be genuinely unobserved is enormously important and is the first thing efficient designs sacrifice. Contact with growing things becomes something closer to a requirement, which is why gardens appear in every serious habitat proposal, not for food, but because plants are among the most reliably restorative environments people have. Variation in color, texture, and layout has measurable effects, which means a 4th-century ship would need its interiors rebuilt repeatedly, not because they wore out, but because they had been looked at too long. Sleep itself would need attention that no short mission has ever had to give it. Sleep quality in orbit is measurably worse than on the ground, with shorter total sleep and a heavy reliance on medication to manage it. That is a workable arrangement for 6 months and an impossible one for 4 centuries, because no pharmacy aboard could sustain it and no population could tolerate it. A generation ship would have to solve sleep environmentally instead, through light, through noise control, through temperature, through the ordinary rhythms of a settled life, and it would have several centuries in which to get it right. There may be an effect on the eyes as well, and it is a quiet one. In an environment where nothing is more than a few hundred meters away, the focusing muscles of the eye almost never relax fully, because there is no distance to relax into. Long-duration crews already show shifts in vision. some of which may be related to exactly this. A population that has never once looked at a horizon across 15 generations would be the first people in the history of the species whose eyes were never asked to look at anything far away. What holds groups together over long isolations turns out to be remarkably consistent across every record we have. Music, ritual, shared meals, and celebration. Not comfort, not entertainment, not privacy alone, but the deliberate marking of time by a group doing something together. A generation ship would develop its own festivals, and they would be festivals with no external referent whatsoever. No harvest moon, no solstice, no anniversary of any event that happened under a sky. They would commemorate departures nobody remembers, repairs that saved everyone, births, deaths, and the crossing of distances that cannot be seen. Within a few generations they would feel ancient, because to everyone alive they would be. And a ship would probably keep places that are hard to get to. Somewhere at the low-gravity end, or out along a maintenance spine, or in a section rarely used, purely so that the world contains somewhere a person has not been. That is not sentimentality. In a world 400 meters across, the existence of an unvisited place may be the only remaining form of distance. Part 6. The first children born aboard. The first shipborne children would arrive early. Within the first 3 decades, before the vessel has even finished accelerating, there would be people aboard who have never stood on anything that was not built. By the 50th year, a substantial fraction of the population has never seen a planet. By the 100th, the last person who remembers a sky is very old. And by the 2nd century, everyone alive was born aboard. Everyone who chose the mission is dead, and the ship is no longer a journey that anybody agreed to. It is simply where everyone lives. That transition happens without a decision being made, and it shows up in language before it shows up anywhere else. People stop saying aboard and start saying here. They stop calling it a ship and start calling it home, or by whatever name it has acquired, and the word for the vessel becomes the word for the world. Nobody announces it. A generation looks back and finds that the change already happened, somewhere in the childhoods they cannot quite remember. The physical question underneath all of this is one nobody can answer. Human development happens under a gravitational load. Bone grows in response to the forces placed on it. Muscle develops against resistance. The balance organs of the inner ear calibrate themselves during the first years of life against a constant, reliable downward pull. No human being has ever developed under anything other than a full Earth gravity. Every child ever born has grown up in the same gravitational environment, without exception, for the entire history of the species. A ship that spins at a fraction of Earth's gravity, in order to keep its radius small and its mass manageable, is therefore running an experiment on its own children. Not once, but 15 times in a row, with no control group, no way to stop, and no way to correct the result if it turns out badly. That is the honest shape of the problem, and it is the strongest argument in the whole design for building a habitat large enough and slow enough to produce a full gravity, whatever it costs to push that mass across 4 light years. There is a gentler possibility alongside it. The inner ear calibrates during development, which means an infant raised in a rotating habitat would learn the world with the rotation already present. The cross-coupled illusions that make an adult from Earth ill might never develop at all in someone whose balance organs were tuned to a turning floor from birth. It is entirely plausible that the shipborne would move through their world with complete ease, at rotation rates that would incapacitate a visitor, and would find the very idea of motion sickness from spin as remote and theoretical as we find the idea of being unable to stand. They would also grow up with a physics that is correct and local. Dropped objects curve. Walking one way is heavier than walking the other. Climbing makes you lighter. The ground rises in the distance instead of falling away. All of that is simply true where they live, and it would be learned before language, absorbed the way a child on a planet absorbs the fact that things fall straight down. It is the recordings of Earth that would look wrong. A film of a ball falling in a perfectly vertical line, in a place where the horizon drops away from the viewer instead of curving up toward them, would look like an effect that had been done badly. And then there is the vocabulary problem, which is stranger and quieter than any of the physical ones. A number of ordinary words would stop having anything to point at. Horizon, weather, ocean, wilderness, rain, night, in the sense of a thing that arrives rather than a thing that is switched on, distance, in the sense of somewhere too far to walk, crowd, in a population of 1,000 where every face is known, wild animal, season, except as a lighting schedule. All of these survive in the archive as accurate descriptions of things that cannot be shown, taught as vocabulary rather than as experience. Scale is the hardest of them. A child whose largest experienced distance is a few hundred meters has no physical intuition for a kilometer and no possible intuition for a light year. The numbers can be taught perfectly well. Arithmetic works the same everywhere. But the feeling that makes a distance mean something, the sense a person on Earth has of what a day's walk is, cannot be transmitted. The shipborne would know the distance to the destination as a figure they had memorized, and would have no more feeling for it than any of us have for the age of the Earth. Earth itself becomes a story. Not a false one, and not a vague one. It would be the best documented place in the ship's archive, with images, recordings, measurements, histories, music, and the accumulated writing of thousands of years. It would be known thoroughly and accurately, and entirely second-hand. Which is to say, it would be known the way any of us know the deep past. Real, important, extensively evidenced, and impossible to verify personally. Nobody aboard could ever go and check. There is a practical consequence of this that shapes the whole society. Education aboard would have to teach two separate physics. There is the physics that governs the ship, which is the one everybody lives in and can test at any moment. And there is the physics that governs planets, which has to be taught entirely theoretically to people who will never once have the chance to confirm it, and most of whom will die without it ever having been relevant to anything they did. The population would also have to be managed in ways that would look strange from Earth and ordinary from inside. Children born aboard inherit an occupation before they inherit a preference, because a closed community of 1,000 cannot support arbitrary career choice. Every critical skill must have successors, and the number of people available to train is fixed. Nobody would be forced exactly, but the shape of what is needed would be visible from early childhood, and everyone would know it. The age structure would need active management too. A closed system cannot easily absorb a sudden increase in births, because the food, the water, the air, and the space are all fixed, and it cannot absorb a shortfall either, because a thin generation becomes a shortage of trained people 30 years later, in every department at once. Reproduction aboard a generation ship is not a private matter in the way it is on a planet. That is one of the deepest ethical difficulties the whole concept raises, and no design has ever solved it in a way that reads comfortably. Death is handled differently as well, and it has to be. Burial is impossible in a closed loop, because the elements in a human body are elements the ship needs. The dead are returned to the system. Every ship culture would build a ritual around that, and the ritual would matter enormously, and it would seem difficult to us, and completely ordinary to them. There is a version of that ceremony in which the water and carbon and calcium of a person continue in the crops, the air, and the bodies of their descendants, and it is not a consolation invented to soften anything. It is simply an accurate description of what happens, all of which produces a reversal worth holding on to, because it runs against the way the story is usually told. We tend to imagine departure as the difficult moment, the wrench, the thing that has to be endured. For almost everyone who will ever live aboard, departure is not an experience at all. It is a date in the record. The difficult moment, the genuinely disorienting one, arrives at the far end, and it belongs to the last generation. They are the ones who will have to walk out of a world whose physics they understand completely into one where the ground curves the wrong way, where objects fall in straight lines, where weight does not depend on which direction you face, and where the sky moves. For the shipborne, a planet is the strange place. Arrival is the shock, not launch. After 15 generations, everyone aboard is related to everyone else within a few steps. The whole population is one extended family, with a genealogy that is complete, documented, and known to all of them. And somewhere in the middle of the crossing, there would be a generation, and then several more, who were born in interstellar space, lived their entire lives in interstellar space, and died there, having seen neither the system they came from, nor the system they were traveling toward. They are the true inhabitants of the voyage. There are more of them than of anyone else. Part 7. The Long Middle. It is worth gathering what we have before going further, because the ship is now fully assembled, and the rest of this is about the people inside it. We have a vessel of perhaps 1 million tons, most of it habitat and shielding and water rather than engine, moving at 1% of the speed of light toward a star 4¼ light-years away, on a crossing that will take something over 4 centuries. We have a habitat turning about its axis to make weight, at a radius of a couple of 100 meters and a rate of about 2 turns a minute, where dropped objects curve as they fall, and walking one direction is heavier than walking the other. We have a closed loop of air, water, and food that has to be maintained without loss for 15 generations, in which the same water passes through people and plants thousands of times, and in which the most serious dangers are slow discrepancies rather than alarms. We have a sky outside that does not change, in which only 2 points of light do anything at all across the entire voyage. And we have a manufactured day, a manufactured evening, a manufactured year, and a permanent low hum that means the ship is alive. That is the world. Everything from here is what happens inside it. And what happens inside it, for most of the voyage, is ordinary life. That is the part that is genuinely difficult to picture, and it is the largest part by far. Somewhere around the 50th year, the ship finishes accelerating and the engines go quiet, and then nothing of consequence happens for approximately 350 years. There is no arrival to prepare for within anyone's lifetime. There is no departure to remember. There is no external event of any kind. There is a world of 1,000 people, working, eating, raising children, arguing, repairing things, growing food, making music, and dying, in a place that is entirely known to them and entirely stable. The mission, in that long middle, is not an experience. It is a background fact, like the age of a country. It appears in education and in ceremony and in the maintenance schedules, and it does not appear in daily life at all, because there is nothing about it to do. A person could live 80 full years aboard, competently and happily, contribute a great deal, and never once take an action whose purpose was the crossing. Their work would be the ship. The ship's work would be the crossing. The two are connected by an argument, not by an experience. This is why the confinement studies are of such limited use. They measure people who are waiting. The middle generations are not waiting for anything. Waiting requires an expected end within the horizon of a life, and there is none. What they have instead is a complete world with a history, a culture, a set of institutions, a body of shared work, and a future that extends past everyone in it. Which is, when you set it out plainly, a fair description of the situation every human being has ever been in. The difference is only that the boundaries are visible and the population is small enough to know. They would have history, and the history would be dense. 400 years is enough for a great deal to happen to 1,000 people. There would be periods that are remembered as difficult and periods remembered as good. There would be a generation known for having rebuilt the agricultural sections, and another known for a failure that was caught late, and another that produced a body of music everyone still knows. There would be old disputes with long roots. There would be places aboard that mean something because of what happened there. All of it would be entirely internal, verifiable by anyone, and unknown to anyone else in the universe. And they would have the mid-voyage problem, though it would not look like the one the studies describe. A crew halfway through a 500-day isolation experiences a slump because the end is still far away. A ship halfway through its crossing experiences something else. The population in the 200th year is as far from departure as from arrival, and both are equally unreachable. The archive describes a place none of them have seen. The forward instruments describe a place none of them will see. They are the generation with the least connection to either end of the story they are inside, and the greatest freedom from both. Whether that is a burden or a release is a genuinely open question, and there is a case for the second answer. A population that has stopped experiencing itself as being in transit has stopped experiencing itself as deprived. They are not people who cannot get to a planet. They are people who live where they live, in a world that provides everything they need, at a scale where every person matters visibly and no work is meaningless. Isolation research is consistent that meaningful work protects morale better than comfort does, and there is no environment on Earth in which the connection between a person's work and everyone's survival is as short and as obvious as it would be aboard a generation ship. There is also the matter of the signal from home, which would be one of the stranger features of the middle centuries. Earth would keep transmitting, and the ship would keep receiving, and the delay would grow every year until it stretched to years and then to a decade, and then further. Everything arriving would be old on arrival and getting older. By the 2nd century, the ship would be listening to a civilization it could not converse with, only overhear. Questions asked aboard would be answered by people who had been dead for a generation before the answer was sent. And the content itself would drift out of usefulness. The news would concern places, institutions, and disputes that mean nothing to anyone aboard, in a language changing at both ends independently. At some point, in most honest accounts of the idea, the transmissions would simply stop mattering and possibly stop entirely. A civilization 400 years on has other priorities than a ship it launched. Whether the silence arrives because Earth lost interest, or lost the capability, or lost something worse, would be unknowable from aboard. The ship would notice a gap, wait, and eventually stop expecting. That moment, whenever it came, would be the real severance, not the departure, not the heliopause, but the year the last message arrived and nothing followed it. The risk runs the other way, and it is the one every serious analysis returns to. The danger is not rebellion. It is not despair. It is forgetting. A population perfectly capable of running its world can gradually lose the understanding of why the world is built the way it is. Procedures get simplified because the reason for the complication is no longer remembered. Inspection intervals get extended because nothing has ever been found. Redundant systems get repurposed because they have never been needed. Each individual decision is reasonable, made by competent people, and slightly wrong, and the errors accumulate across generations in a direction nobody is watching. That is why the ship's culture would have to do something no terrestrial culture has ever managed, which is to transmit not just skills but reasons, intact, 15 times in a row. And skills degrade faster than almost anything. A trade with no one currently practicing it is gone within a single generation, regardless of how well it has been documented, because documentation preserves the steps and not the judgment. The ship would need people practicing skills that are not currently needed, purely so that they exist when they are. There is one more feature of the long middle that is easy to overlook. The ship gets old. Not dangerously at first, just visibly. Surfaces wear. Sections are rebuilt in the style of whatever generation rebuilt them, so the habitat accumulates layers the way a city does. There would be original fittings from the departure, treated with the care given to anything that has lasted, and there would be sections that have been replaced 4 times. Somewhere aboard there would be a part of the structure that has never been touched, original to the departure, still bearing whatever markings were put on it by hands on a planet, and everyone would know exactly where it was. It would be the oldest thing in their world, and the only object any of them could point to that had been made somewhere else. By the 250th year, the ship contains more history than the mission does. The archive of Earth is enormous, complete and inert. The archive of the ship is smaller, growing and alive, and it is about people whose descendants are in the room. A society's attention goes to the second of those, inevitably and without anyone deciding, and the crossing recedes to become what it has always effectively been for everyone in the middle, the reason the world exists rather than anything happening to it. Part 8. A world nobody can leave. The first crew volunteered. Nobody else did. That single asymmetry sits underneath every question of how a generation ship would organize itself, and it does not go away with better engineering, better design, or better intentions. Every person born after the first generation arrives into a mission they did not choose, in a place they cannot leave, bound by obligations set by people they never met and could not have argued with. There is no version of the concept in which this is not true. The usual response to this is that nobody consents to the circumstances of their birth. Nobody chooses their country, their century, their family, or the state of the world they inherit, and the shipborn would inherit a rich, purposeful, materially secure environment in which their work matters visibly and their position is understood. That is a serious argument, and it is not obviously wrong. But it is also not the same situation, because the borders of a country can be crossed, and the hull of a ship cannot. Emigration is the release valve on every other human political arrangement, and aboard it does not exist. Whether the inheritance is sufficient compensation for that is a question the episode should leave open, because it is genuinely open. The practical form of the problem is not resentment. It is drift. A population that is competent, comfortable, and at home has no strong reason to prioritize an arrival that none of them will see. Maintaining the deceleration systems, preserving the arrival skills, keeping the destination data current, and paying the mass and power costs of a mission nobody alive will experience are all things that require a reason. And the reason is entirely abstract. Nothing aboard forces the population to remain committed to the crossing. They could, at any point across 3 centuries, simply stop treating it as important, and the machinery of the ship would go on working perfectly well. Which puts a great deal of weight on institutions, and institutions are not encouraging on this timescale. Very few human organizations have run continuously for 500 years with their purpose intact. The ones that have managed anything close are religious orders and a handful of universities, and in every case the purpose shifted substantially along the way. No government, no company, no agency, no scientific program has ever held a single objective steady across 15 generations. There is no precedent for what a generation ship needs to do, in any culture, at any point in recorded history. The systems that cannot be allowed to lapse are specific and unforgiving. Life support maintenance, agricultural continuity, population management, the training pipeline for every critical skill, with no gaps, ever. And the archive, which has to be copied forward, verified, and kept readable. Each of those has to survive not just accidents, but ordinary human things: boredom, reform, factionalism, a generation that decides its predecessors were wrong about something, and the slow erosion that comes from doing anything the same way for 400 years. The governance arrangements that have been proposed are all recognizable and all have obvious weak points. Rotating councils, which spread authority and dilute expertise. Technocratic guilds tied to critical systems, which concentrate expertise and create hereditary power. Constitutional documents treated as unamendable, which work exactly until a situation arises that the document did not anticipate. And, in some analyses, a deliberately maintained shipboard religion or ideology built around the mission on the grounds that belief transmits across generations more reliably than policy does. Every one of those has failed somewhere on Earth, on much shorter timescales. There are also constraints that the environment simply imposes. Aboard, punishment is arithmetically difficult. There is no exile because there is nowhere to send anyone. Imprisonment wastes labor a small population cannot spare. Execution removes an irreplaceable set of skills and a portion of a gene pool that cannot be replenished. Whatever justice aboard looks like, it would have to be restorative rather than punitive, not for philosophical reasons, but because the alternatives do not work in a closed system of 1,000 people. Conflict has the same problem. On a planet, serious social ruptures resolve geographically. Factions separate, communities split, people move away, and distance does the work that agreement could not. Aboard, a rupture has no physical outlet whatsoever. The losing side of any dispute continues to live in the same corridors, eat the same food, and work the same shifts as the winning side, indefinitely, and their grandchildren will do the same. A ship's culture would have to be extraordinarily good at ending arguments, and would probably develop formal machinery for it that would look elaborate and ceremonial from outside and entirely necessary from within. There is a decision-making oddity underneath all of it that is worth stating directly. Any vote taken aboard about the mission is taken by people with no stake in the outcome. The arrival is centuries beyond every voter's lifespan. There is no version of shipboard democracy in which the people deciding are the people affected, and no version in which the people affected can be consulted, because most of them have not been born. Every political system aboard is a system for making decisions on behalf of the unborn, permanently, with no feedback of any kind. It is worth noticing what the long-lived institutions on Earth actually have in common, because it is not what a modern engineer would expect. They are not the ones with the best documentation. They are the ones that reproduce themselves through ritual and through training, through daily practice performed by people in the presence of other people, repeated so often that it becomes the medium the institution is made of, rather than a description of it. Monastic orders, craft apprenticeships and academic traditions have carried very specific behaviors across 1,000 years, not by writing them down well, but by never once letting a generation go by without someone doing them. A ship that wanted its life support discipline to survive 4 centuries would probably have to make it ceremonial, and would probably be right to. There is a governance question nobody has satisfactorily addressed, and it belongs here. Propulsion improves. A second ship, launched a century after the first at 3 times the speed, arrives centuries earlier. The first ship's population could learn by radio, decades before their own arrival, that the destination has already been settled by people who left long after they did. Nothing in any proposed shipboard constitution says what a population owes to a mission that has already been completed by somebody else. It is a genuinely novel political situation, and it is entirely plausible. Privacy is the other constraint, and it is the one most likely to be designed away. In a world of 1,000 people where every function is shared and every resource is monitored, the ability to be genuinely unobserved is scarce and expensive, and in closed environment research is unanimous that it matters enormously. A ship that optimizes for efficiency would remove it first, and would not find out what that cost until several generations later. This is why several analyses conclude that the destination should be kept visible and celebrated rather than merely recorded. An abstract goal in an archive cannot compete for attention with the concrete business of running a world. A star that everyone can point to, that appears in ceremony, that has festivals attached to it and is taught to children as the reason their world exists, has a chance of surviving 15 generations. A line in a founding document does not. And there is a more radical proposal that deserves airing, because it dissolves the problem rather than solving it. Some analyses suggest that a generation ship should carry no fixed destination commitment at all. It should be built as a mobile, self-sufficient habitat whose population may stop somewhere if they find a reason, and may not. On that view, the ship is not a vehicle carrying settlers to a planet. It is a way of living that happens to be in motion, and its success is measured by whether the world inside it endures, not by whether it lands. That reframing removes the consent problem almost entirely, because nobody is being carried anywhere against their inclination. It also quietly removes the mission. The failure everyone genuinely worries about, though, is none of these. It is not mutiny, not tyranny, not collapse, and not a population that refuses to go on. It is a population that goes on perfectly well, while gradually losing the understanding of what it is doing and why the machinery around it is shaped the way it is. That failure is silent. It is made entirely of reasonable decisions, and it would not be visible to anyone aboard until something needed to work and did not. Which brings the whole question back to the archive and to a room that is not a library but a maintenance problem. Storage media degrade. Formats are abandoned. The machines that read them wear out and have to be rebuilt aboard from parts made aboard. Somebody's full-time occupation, in every generation for 15 generations in a row, is copying the past forward so that it stays readable. It is the least glamorous job on the ship, and it is the one the arrival depends on. Part 9. Bodies and Bloodlines. Outside a planetary magnetic field, the galactic cosmic radiation delivers something like half a millisievert to a millisievert per day to an unshielded human body. That is roughly the dose of a medical scan, every day, without pause. Over a 400-year crossing, it accumulates into hundreds of sieverts, against a dose of about 5 that is lethal to half the people who receive it at once. There is no version of this in which shielding is optional. It is the precondition for the entire concept, and everything else about the ship's design bends around it. The radiation itself is not what most people picture. About 87% of it is bare protons, and roughly 12% is helium nuclei, but the remaining 1% consists of heavier nuclei stripped of their electrons, traveling at a large fraction of light speed, and those do a wholly disproportionate share of the damage. The energy a charged particle deposits scales with the square of its charge, which means a single ion nucleus deposits several hundred times what a proton does along the same path. It is a small population of particles doing most of the harm. That produces the design paradox that governs everything. A thin or moderate metal shield can be worse than no shield at all. An incoming heavy nucleus striking aluminium shatters, and the collision produces a shower of secondary particles, including neutrons, that spreads out behind the shield and can deliver more dose to the body than the original particle would have. Adding a modest amount of metal makes the problem worse. What works is bulk, and specifically hydrogen-rich bulk, water, polyethylene, biomass, because hydrogen nuclei are single protons that break incoming particles down without producing heavy fragments. The quantity required is where the generation ship gets an unexpected advantage. Matching the protection Earth's atmosphere provides means carrying something like 10 tons of mass per square meter, which is roughly 10 meters of water standing above your head in every direction. For a small probe, that is impossible. For a ship whose habitat is already surrounded by water reserves, growing beds, food stores, and structural mass, it is very nearly free. The shielding is not a layer added to the ship. It is the ship, arranged thoughtfully. There is a second advantage that comes directly from going slowly. At high fractions of light speed, the thin interstellar gas the ship runs into arrives as a forward beam of energetic particles, and it becomes a hazard in its own right. At 1% of light speed, those same atoms arrive with energies far too low to matter at all. The slow ship is genuinely safer, and this is one of the few places in the entire design where a constraint works in the traveler's favor rather than against them. Then there is the gene pool, which is a finite resource in the most literal sense. Estimates of the minimum viable population for a multi-century crossing range widely, and the range itself is the honest answer. With strict, continuously managed pairing rules and careful record-keeping, simulations suggest a population of around 100 could hold together genetically across many generations. Left to organize itself naturally, the number rises into the high hundreds or the low thousands. The difference between those figures is not biology. It is how much control the ship exerts over who has children with whom, and that is a question about the kind of society aboard rather than about genetics. Two things erode a small, closed population. The first is inbreeding depression, where harmful recessive traits that stay hidden in a large population begin to surface as everyone becomes related to everyone else. The second is genetic drift, where variation is simply lost to chance, generation by generation, because a small number of parents cannot represent the full range of what the founding population carried. Neither can be reversed from inside, because there is nothing outside to breed with. The variation that boards the ship is all the variation that will ever exist aboard it. The standard mitigation is a frozen store of genetic material carried from Earth and drawn on across the centuries, reintroducing variation that would otherwise have been lost. It works, and it is probably necessary, and it makes the ship's ancestry partly archival. Some of the parents of the 12th generation would be people who never left the solar system and never knew the ship existed. Selection would keep acting the whole time. A closed environment with its own light, its own diet, its own gravity, its own pathogens, and its own daily rhythms exerts real pressure, and 400 years is enough for that pressure to show. What arrives at the destination is not the population that departed. It is a population measurably shaped by 4 centuries of living aboard a spacecraft, and that shaping runs in exactly the wrong direction for the thing they were sent to do. There are more aggressive proposals, and they are worth naming because they change what the arriving population is. A ship could carry frozen embryos as well as gametes, which raises the possibility of deliberately expanding the population partway through the crossing from stock that predates everyone alive. A generation could, in principle, be substantially composed of people whose parents were never aboard. Gene editing is also raised as a way to shrink the minimum viable population, or to repair accumulated damage, or to adjust the arriving people toward whatever the destination turns out to require. Each of these works on its own terms. Each of them also makes the population that steps off the ship a designed one rather than a descended one, and that is a different thing from the one that departed in a way no document could capture. It is worth saying plainly what the accumulated picture is here, because it is easy to lose in the detail. Nothing in this section is a barrier. Radiation is solved by mass the ship already carries. The gene pool is solved by management and by a frozen store. Medicine is solved by an onboard industry. Disease is solved, in a sense, by isolation itself. Every one of these has an answer. What none of them has is an answer that can be applied once and then left alone. Each is a discipline that has to be practiced correctly by trained people without a lapse for 400 consecutive years. The difficulty of a generation ship has never really been any single problem. It is that there are 40 of them, and all of them are permanent. Medicine aboard has a harder problem than any of this, and it is the simplest one. The pharmacy expires. Medicines degrade over time, and radiation accelerates the process, and no plausible manifest carries 4 centuries of drugs. Everything has to be synthesized aboard, which means a working chemical industry maintained as a life support system, with the knowledge, the equipment, and the feedstocks all reproduced generation after generation. Surgery is possible, but nothing about it is easy. Nobody has ever performed surgery in space. Blood behaves differently without gravity, and even in a habitat spinning at a comfortable rate, the surgical team, the instruments, the sterile technique, and the training all have to be reproduced across 15 generations with no outside institution to certify any of it. The unglamorous specialities are the ones that cannot be lost. Dentistry, obstetrics, and trauma care are each individually capable of ending a person and collectively capable of eroding a population, and none of them can be learned from a document alone. Disease aboard would take an odd shape. A closed community eventually clears the infections that need a large host population to persist, which means that within a few generations, the ship might be remarkably free of the ordinary illnesses that follow people everywhere on Earth. The cost of that is a population with no exposure, and therefore no immunity to anything, which makes any reintroduction, a dormant strain surviving in storage, or something encountered at arrival, considerably more dangerous than it would be for people who had grown up among such things. The ship's own biology would drift too. The bacterial communities on people, on surfaces, and in the water system change in enclosed habitats, and the bacteria found in long-sealed environments have shown increased virulence and increased resistance to treatment. The microbiome of a generation ship is not a fixed background. It is an evolving population with a 400-year head start on whatever the medical section knows about it. And the body itself would keep asking for maintenance. Immune function is measurably suppressed in spaceflight, with latent viruses reactivating. Wounds heal more slowly, which turns minor injuries into extended events and pushes the whole culture toward caution about physical risk. Exercise as a countermeasure is not a personal habit, but a system, hours per person per day, on machines that must be maintained, with spare parts that must be manufactured, for 400 years without interruption. There is one final complication that no shield addresses. A human body contains naturally radioactive elements, potassium and carbon among them, decaying at thousands of events per second inside the tissue itself. On Earth, that is unremarkable, because the body repairs the damage continuously and always has. Aboard, it is a reminder that a person is not something you can put behind a wall. Part of the exposure is arriving from inside, and it has been there the whole time. Part 10. The drift of everything. Language changes faster than people expect, and it is the quiet clock running underneath the whole voyage. English of 400 years ago is readable with effort and noticeably foreign in vocabulary, in spelling, and in idiom. It requires footnotes. A ship crossing at 1% of the speed of light spans exactly that much linguistic change, in complete isolation, with no external standard to correct against. The slower designs run past 1,000 years, which is the span from Old English to Modern English, and at that point, the arriving population could not converse with the departing one at all, without formal study. Isolation accelerates the process rather than slowing it. Small, separated speech communities diverge faster than large, connected ones, and a ship is the most isolated speech community it is possible to construct. Words for shipboard things would proliferate, because that is where all the experience is. Words for planetary things would fossilize into formal vocabulary, used correctly in education and never used casually by anyone. New distinctions would appear that no terrestrial language needs, for directions of rotation, for gravitational levels, for the various states of a life support system, and those would become the ordinary words of daily life. The technical vocabulary is where this stops being interesting and becomes a problem. The working language of the life support crews will drift because working languages always do. The manuals will not, because they are written down. Once those two have separated far enough, the manuals stop being usable, not incomprehensible, just subtly misleading, describing a procedure with words that no longer mean quite what they meant. Nobody notices until something breaks in an unfamiliar way, and the documentation turns out to be describing a different thing from the one everyone has been calling by that name for 2 generations. The archive underneath all of this has 3 separate problems, and they get harder in order. The first is media. Every storage medium has a lifetime, and none of the ones currently in use is confidently rated for centuries. Data has to be actively copied forward, continuously, for as long as the ship exists, and every copy is an opportunity for loss. The second problem is readers, and it is worse. Data is useless without a machine that reads it and software that interprets it. Both of those must be manufactured aboard, out of parts made aboard, by people trained aboard, to specifications written by people who assumed that the manufacturing base of an entire planet would be available. A ship might reasonably decide to keep a deliberately primitive layer of the archive alongside the sophisticated one, text, etched into metal, printed on durable stock, readable by eye with no machine at all, precisely because a format that needs nothing cannot be orphaned. The third problem is context, and nobody has solved it anywhere. An instruction that assumes a shared background stops working when the background changes. Long-term record-keeping research has spent decades on the question of how to communicate across 10,000 years, mostly in the context of warning future people away from buried hazards, and the researchers involved have never produced a solution they are confident in. The message survives. The ability to understand it does not. Units drift, assumptions go unstated, and the things everyone knew and therefore never wrote down are exactly the things that disappear. Skills fail faster than any of this. A trade with nobody currently practicing it is gone within a single generation, no matter how thoroughly it has been documented, because documentation preserves procedure and not judgment. The difference between a manual and a craftsperson is that the craftsperson knows which of the steps matter, what a thing sounds like when it is right, and which of the tolerances are real. None of that is written down, in any field, anywhere. It is transmitted by working alongside someone. A ship would therefore have to keep people practicing trades that are not currently needed, doing work that does not need doing, purely so that the capability still exists in the generation that will need it. That is an expensive and slightly absurd commitment, and it is unavoidable. Which leads to something that would happen whether anyone planned it or not. After enough generations, a record that nobody can independently verify stops functioning as data and starts functioning as inheritance. The archive would be true, and it would be treated with a seriousness that would look, from outside, very much like reverence. That is not a corruption of the archive. It may be the only thing that preserves it. Cultures that encoded critical information in story, in ritual, in song, and in obligation have carried it across spans far longer than cultures that wrote it down and filed it, because a story gets repeated and a file gets forgotten. Measurements drift as well, and that one is genuinely dangerous. Units get adjusted for local convenience, because a ship has no need for a day based on a planet's rotation, no need for a year based on an orbit, and no natural use for distances scaled to the size of a world nobody has seen. Over centuries, a population would quietly develop its own units for the things it actually measures: habitat sections, rotation periods, growing cycles, water volumes. Each redefinition is sensible. Together, they gradually remove the ability to check the ship against its own original engineering documents, which are written in units that no longer correspond to anything anyone uses. The countermeasures are all obvious and all partial. Keep the archive in several formats. Keep copies in physically separate parts of the ship so that no single failure takes them all. Keep at least one layer that requires no technology to read. Verify continuously rather than periodically, because a corrupted copy discovered a century late is not a copy. And maintain a group of people whose entire function is fidelity, not improvement, not innovation, not efficiency, but keeping things exactly as specified, checking that the words still mean what they meant, and resisting the reasonable, well-intentioned, individually harmless changes that add up to a ship that can no longer read its own instructions. That role would be strange to hold. It is a job with no visible product, whose success looks identical to having done nothing, and whose failures only become apparent generations after the person responsible has died. It is also, plausibly, the most important occupation aboard. Every other discipline on the ship can be rebuilt from the archive if it is lost. The archive cannot be rebuilt from anything. So Earth would exist aboard as three things at once, all of them accurate. It is a set of coordinates and a point of light in the rear sky. It is an enormous, complete, meticulously maintained collection of images, recordings, measurements, music, and writing. And it is a word people use for the place everything came from, carrying whatever weight 14 generations of use have given it. All three are correct. None of them is a memory. Nobody aboard has one, and nobody aboard for the last 300 years has known anyone who did. The same drift applies to what the ship knows about where it is going, and this is the one with practical consequences. Everything in the destination file was gathered from 4 light-years away, by instruments that no longer exist, operated by people whose language the ship's population can no longer speak fluently, and it was already old when the ship departed. On arrival, it is 4 centuries older. The orbits will have moved. The assumptions may have been wrong. Anything about the target that depended on a measurement will have to be established again from scratch, on approach, by people who have never done it. There is one more form of drift, and it is the most human of them. Meaning changes. The mission was undertaken for reasons that made sense to a particular civilization at a particular moment, reasons about survival, or expansion, or curiosity, or something else entirely. Those reasons are carried aboard as text. But a reason is not a fact, and a reason that was compelling to people living under an open sky, with a crowded world and a specific set of fears, may not be compelling at all to people living in a closed one, 4 centuries later, who have never seen a crowd and have never been afraid of anything the founders were afraid of. The ship would go on regardless. That is the strange comfort in it. The machinery does not require anyone to be moved by the original argument. It requires only that the water keeps circulating, the lights keep cycling, the crops keep coming in, and the children keep being taught. The reasons can drift as far as they like. The velocity does not. Part 11. Failures that take centuries. No human-built spacecraft has operated for much more than half a century. The ones that have come closest are simple, cold, mostly switched off, and coasting. A generation ship needs a complex, warm, continuously running system to last 8 times longer than anything we have ever managed, while supporting people the whole time. That gap between 50 years of demonstrated operation and 400 years of required operation is the largest unproven number in the entire concept, and it is not the kind of gap that can be closed by testing. The physical processes that wear a ship down are all slow and all well understood. In vacuum, clean metal surfaces have no oxide layer to keep them apart, and 2 such surfaces pressed together will bond. Every hinge, bearing, and mechanism exposed to vacuum is a slow seizure waiting to happen, and the standard remedies, coatings, lubricants, deliberate contamination of the surfaces, are themselves materials that age. The soft materials fail long before the structural ones. Plastics, adhesives, seals, gaskets, and insulation embrittle under sustained radiation and outgas steadily in vacuum, losing the volatile components that made them flexible. A seal that was designed for 30 years and has been in place for 200 is not a seal, whatever the drawing says. Metals swell and embrittle under sustained heavy particle exposure, which is manageable across decades and becomes a genuine design driver across centuries. Semiconductors have a total dose limit, and shielding electronics is easier than shielding people, but it is not free. And then there is the failure mode that defeats the usual answer. Redundancy protects against accidents. It does not protect against age. 3 identical components, installed at the same time, made from the same batch, operating in the same environment, will fail at approximately the same time, for the same reason, and the reason will be that they are old. Duplication buys nothing against a common cause, and on a 4-century voyage, the common cause is simply the passage of time. All of which means the spares run out. No plausible manifest carries 400 years of replacement parts for everything aboard, because the mass of the spares would exceed the mass of the ship several times over. The vessel has to be able to make almost everything it contains, from materials it carries, recovers, or recycles. That requires an industrial base: refining, casting, machining, electronics fabrication, chemical synthesis, and the tooling to make the tools. On Earth, those capabilities are distributed across thousands of specialized organizations and millions of people. Aboard, they belong to perhaps 1,000 people who also have to grow their own food. The consequence is that simplicity beats performance, every time, in every system. Every analysis of very long-duration engineering arrives at the same conclusion. The maintainable version of a system outlives the efficient version by a wide margin, and a ship should be built out of the fewest distinct parts it can manage. Standardization matters more than optimization. A component used in 40 places is worth more than a better component used in one, because 40 of them justify keeping the capability to make them. A ship would probably also carry an entirely mechanical, non-electronic backup layer for its most critical functions, because a mechanism can be looked at, understood, and remade by hand by someone who has never seen the original drawing. Which means that over 400 years, most of the vessel is replaced. The ship of Theseus stops being a philosophical puzzle and becomes a maintenance record. The vessel that arrives is the same ship in continuity, in design, and in name, and almost none of it is the same material. Somewhere in the middle centuries there is a year in which the last of the original mass falls below half, and nobody marks it, because nobody is counting. Outside, the erosion is continuous. At 1% of the speed of light, the forward surfaces are being struck by interstellar dust for 4 straight centuries. The grains are rare, roughly 1 per million cubic meters, but a microgram grain at that speed carries kinetic energy comparable to a rifle bullet, and the ship sweeps an enormous volume. The standard defense is a sacrificial shield well ahead of the vessel, a thin outer sheet that shatters an incoming particle into a spray, and a spaced inner wall that absorbs the spray. An ice shield is particularly attractive because it doubles as radiation shielding, as water reserve, and potentially as reaction mass, and it can be resurfaced from onboard stores as it erodes. Power is its own long problem. The compact radioisotope sources that have run our outbound probes decay with a half-life of about 88 years, which means that after 4 centuries, well under 1% of the original output remains. They are simply not an option for a voyage of this length. A generation ship has to run on fission or fusion, which means a reactor with moving parts, control systems, fuel handling, and a maintenance requirement, operating continuously for 15 generations, tended by people who inherited it. And the power demand is not small, because every calorie of food aboard is grown under artificial light, and the lights are on for most of every manufactured day, for 400 years. Self-repairing systems and onboard manufacturing are the usual answer to all of this, and they are a real answer, but they shift the problem rather than removing it. If the ship can make its own parts, then the factory is the thing that must never break. If the factory can make its own parts, then the tooling that makes the tooling is the thing that must never break. The chain has to terminate somewhere, and wherever it terminates is a capability that has to be preserved by hand, by people, across 4 centuries with no fallback. The ship's architecture would reflect all of this. Rather than one great pressurized volume, a generation ship would more likely be an archipelago of separately sealed sections with independent atmospheres, independent water, and independent power feeds, connected but isolable. A hull breach, a fire, a contamination, or a blight can then take one section without touching the others. It makes the ship heavier, more complicated, and less efficient in every measurable way, and it is almost certainly what a vessel that expects to survive 400 years would look like. The whole design philosophy comes down to a single principle: assume everything will fail, assume nothing can be delivered, and build so that no single failure can reach everyone. Heat is the constraint that never lets up. Everything the ship does, every light, every pump, every person, every crop, ends up as waste heat, and the only way to lose heat in vacuum is to radiate it away. That requires radiator area. Radiator area scales with power, and every square meter of it is mass that has to be accelerated at the start of the voyage and decelerated at the end. The ship is permanently negotiating between how much life it can support and how much of that life's exhaust it can throw away. Software deserves its own mention, because it ages in a way nothing physical does. Code written 4 centuries earlier, in a language nobody speaks conversationally anymore, running on hardware manufactured aboard from a specification nobody can independently test against, controlling systems that people's lives depend on. It cannot be rewritten safely, because the people who understood why it does what it does are long dead. It cannot be left alone, because the hardware underneath it keeps changing. Every generation inherits a body of instructions it did not write and dares not fully touch. The result of all this is that emergencies aboard would rarely look like emergencies. In a world this size, catastrophe arrives as duration. A bearing that has been running 2 degrees warm for 11 years. A pressure vessel whose inspection interval was quietly extended 3 generations ago by someone competent and reasonable. A corrosion pattern nobody recognizes, because nobody in the history of the species has kept a machine alive long enough to see it. There is no alarm for any of that. There is a slow accumulation of small wrongnesses, and a culture that either notices them or does not. And there is one item that sits apart from all the others, because it has to work exactly once. The propulsion system spends the overwhelming majority of the voyage switched off. It was built by people 4 centuries dead, maintained by people who have never seen it run, and it has to start again, correctly, on schedule, at the midpoint of the crossing, and then perform for decades. Every other system aboard proves itself daily. That one does not prove itself at all until the moment it matters, and by then there is nothing anyone can do about it except what has already been done. Part 12. Turnover, approach, and arrival. Deceleration is half of the mission, and it is routinely left out of the discussion entirely. Almost every fast interstellar concept ever published is a flyby design. The probe reaches its target, passes through the system in a matter of hours, gathers what it can, and continues into the dark on the other side forever. That is an acceptable outcome for an instrument package. It is not an acceptable outcome for a ship carrying people, and shedding all of that speed costs approximately as much as gaining it did. Every honest account of a crewed crossing is really an account of 2 voyages, one to get up to speed and one to get rid of it. For a ship using its own engine, the shape of that is the turnover. At the midpoint of the crossing, the vessel rotates end for end and begins to burn against its own motion. For everyone aboard, this is the single most significant event in the entire middle of the voyage. It would be scheduled generations in advance. It would be prepared for by people who would not live to see it, and executed by people who had grown up hearing about it. And in a world where nothing external ever changes, it is the only thing that ever does. The direction of everything reverses. The engines, silent for 200 years, start again. And for the first time, the destination stops being a name and becomes a thing the ship is actively doing something about. There are ways to slow down without carrying fuel for it, and they are elegant. A magnetic sail, deployed as the ship approaches, can push against the destination star's outflowing wind of charged particles. A light sail can be turned to catch the destination star's own light and use it as a brake. Both work better the closer the ship gets, which produces an unusual final act. After 4 centuries in which nothing accelerates or decelerates or changes at all, the last stretch is the fastest changing period of the entire voyage. The universe outside finally starts doing something, and it does it just as everyone has stopped expecting it to. The approach itself would still be measured in decades. This is not a matter of days. The final deceleration phase alone could run for 30 or 40 years, and across that time the target star does what nothing has done for 400 years. It changes visibly. It brightens noticeably from year to year. It separates into two distinct points as the yellow star and its orange companion draw apart in the sky. Eventually, in the last stretch, it stops being a point at all and becomes a small disk with a measurable width. Some person aboard would be the first human being in 15 generations to look at a star and see a shape. That generation has a problem nobody has prepared them for, and it is not a technical one. The crew that departed had never crossed interstellar space, and they knew it, and they trained for it. The crew that arrives has never approached a star system. They have never entered an orbit, never made an atmospheric entry, never landed anything anywhere, never surveyed a planet, never dealt with a gravity well. Every arrival skill aboard has been theoretical for 400 years, taught by people who never used it to people who never used it, 15 times in a row. The last generation is as inexperienced as the first, and they are inexperienced at something considerably harder. The information they are working from is 4 centuries old. Everything in the destination file was gathered from 4 light-years away by instruments that no longer exist. The orbits have moved. The measurements were made at the limits of what was possible. Anything that mattered would have to be re-established from scratch, on approach, in real time, by people doing it for the first time. That is the actual work of the arrival generation, not landing, but finding out where they are. And the place they have arrived at is not a home. It is a hostile environment with unknown chemistry, unknown weather, unknown biology if there is any, and no infrastructure of any kind. The ship, meanwhile, is comfortable, thoroughly understood, entirely theirs, and has been keeping people alive without interruption for 400 years. It is by an enormous margin the safest environment any of them will ever occupy, and every one of them knows it in their body rather than as an argument. So, there is a real possibility, taken seriously in several analyses, that they simply do not land. A ship that has successfully sustained a population for 4 centuries has already solved the problem the planet was supposed to solve. It has demonstrated closed-loop life support, sustainable population management, industrial self-sufficiency, and social continuity across 15 generations, which is a more complete solution to living somewhere than any planet offers on arrival. The population could stay aboard, mine the small bodies of the new system for the raw material the loop has slowly lost, build a second ship, and continue, and by every practical measure that is a successful mission, differing from the original intention only in the intention. The navigation into a triple system is genuinely awkward as well, and worth a moment. 2 stars orbiting each other on an 80-year ellipse do not leave the same stable regions available that a single star would. Orbits close to either star are safe, and orbits far outside both are safe, and a considerable band in between is not, because the 2 stars keep reshaping it. Choosing where to stop is a real decision, with real consequences, made once, by people who have never chosen an orbit before, on information gathered 4 centuries earlier, from 4 light-years away. Communication would have gone strange by then too. From the destination, a message home takes over 4 years to arrive, and any reply takes another 4. The arriving generation could announce what they had found, and would receive an answer, if an answer came at all, from a civilization 9 years further on than the one that heard them. Nobody in that exchange would ever meet. It is less a conversation than 2 archives writing to each other. And it is worth naming what the alternatives to all of this look like, since a generation ship is not the only proposal. There is deep torpor, in which the crew sleeps through the crossing, and no human being has ever been revived from anything approaching it. There is the embryo ship, which carries frozen cells and machines that raise the first children at the far end, which requires a machine to run unattended, correctly, for 4 centuries, and then to parent. Set against those, the generational approach has one enormous advantage. It uses no technology that does not exist, and it keeps people awake and in charge the whole way. Everything difficult about it is difficult in the ordinary human way, rather than in the way that requires a discovery. There is one further possibility, and it is the one that would be hardest to receive. Propulsion improves. A ship launched a century later, at 3 times the speed, arrives centuries earlier. It is entirely plausible that the descendants of the first crossing would learn, by radio, decades before their own arrival, that the system ahead of them has already been settled by people who left long after they did. Some analyses take this seriously enough to conclude that the rational decision is always to wait, which produces the neat paradox that a civilization which always waits never goes anywhere at all. The counter-argument is that waiting assumes continued progress and continued stability, and neither of those is promised to anyone. A ship already underway is insurance against a future that does not arrive. Which brings the whole thing back to where it started, and to the honest shape of it. A generation ship is called an impossible journey, and the word is precise, but it is not impossible in the way people usually mean. Nothing about it violates any law of physics. There is no barrier out there, no wall, no forbidden thing. It is impossible only in this sense: it cannot be made by a traveler. There is no person who can undertake it. A human life is simply too short a unit for the distance, by a factor of 5, and no amount of engineering changes that at these speeds. The crossing is not available to anybody. It is available only to a lineage, which is a very different kind of thing, something that has to be handed along, intact, through 15 sets of hands that never meet. And that is what the ship really is. It leaves as a vehicle. Within a century it has become a world, and it stays a world for 300 years, with a history, a culture, festivals, disputes, music, and a graveyard that is also a garden. And then, in the lifetime of one final generation, it turns back into a vehicle and does the thing it was built to do, for people who had almost stopped thinking of it as a thing that could be done. But the part that matters is not the arrival, and it never was. It is the middle. It is the several hundred years in which 1,000 people, born and dying in the deepest dark there is, ran a world properly. Kept the water clean, brought the crops in, held the archive readable, taught the children 2 kinds of physics, and turned the lights down in the evening because it was good for people to have an evening. Nothing out there noticed. Nothing out there ever does. And so the ship goes on, carrying its small manufactured evening through a dark that does not change, with everyone who built it long gone, and everyone who will arrive not yet born. Somewhere in the middle of that long crossing, a world is simply being lived in, quietly and carefully and well. Let your breathing slow. Let the hum settle around you. Sleep well, and good night.